Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is set 4 of 5 good problems on the chapter of time and work. If you have not watched the previous 3 sets where I have also solved 5 good problems, then I strongly suggest that you please watch them to have a good practice of relatively harder problems on the chapter of time and work. Also, I have completed the theoretical concept and problem solving on this chapter in the other playlist, that is CBSE Maths 8 R.S. Agarwal, following the textbook of author R.S. Agarwal. If you have not watched those videos, you can also watch those videos on the chapter of time and work, which will give you a good foundation to solve these relatively harder problems. So this video is part of the playlist Maths 8 Hot. Hot HOT stands for High Order Thinking Problems, where I solve relatively harder problems than the problems that I solved from the textbook of author R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos for the first time, or if you are and if you are and if my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 4 on the chapter of time and work. Okay, so I have all the, so on the left hand side I have kept in this video I'm in a different machine. So I the canvas, the software that I'm using, that document file where I was supposed to solve these problems is in another machine. So I'm referring the PDF version of the 5 good problems, which you can see on the left hand side on the top, and below I have reference of the key concepts and formulas that I will use to solve the problems. And while I will solve a problem, I will refer the concept number at a particular step. Okay, so let me quickly check if everything is properly visible or not. I hope you can, the fonts of the problems as well as the key concepts are big enough so that you can uh, see them properly. Okay, so let's start solving the problems. The first problem says, uh, A and B working together can finish a piece of work in 10 days. If A does 40% of the work, then in how many days will B alone complete the work? If A does 40% of the work, means in the total work, that 40% of the total work. Now, total work is always 1. Okay, so let's start question number 1. So A does 40% of the work. What does it mean? A does 40. My machine is running very slow. I have no idea why. A does 40% of the work. This implies that work done by A in 10 days, that in 10 days the total work was done, the total whole work was done. And so of the total work, 40% of the work has been done by A. So work done by A in 10 days, we can say, is that 40% of a whole work. Now I am really having some problem with this writing because the machine is working very slow. I hope I will be able to write it properly so that you can read it. So 40% of whole work. Now 40%, this is equal to 40% of whole work is always considered the value of 1. So this is 40% of 1. So basically this is 40 by 100. 40 by 100, this is equal to 2 by 5. So the total work done by A is 2 by 5, this means also means that 2 by 5th part of the total work was done by A. Okay, so we can say now the remaining part obviously must have been done by B, because in 10 days the total work was done by both A and B. So we can say work done no, work done by B in 10 days will be equal to the whole work minus the work done by A. The whole work is 1 and the work done by A is 2 by 5. So this is 1 minus 2 by 5. This is equal to 3 by 5. So you can consider the work done by B in 10 days is 3 by 5, which also means that 3/5 part of the whole work was completed by B in 10 days. Okay, now from here we can say that in 10 days work done by B was 3 by 5. We can say that work done by B in 1 day using basic unitary method, we can say will be equal to 3 by 5 divided by 10. This is equal to 3 by 50. 3 by 50. So work done by B in 10 days is 3 by 5, and therefore work done by B in 1 day should be equal to 3 by 5 divided by 10, which this is basic unitary method, which is equal to 3 by 50. Now from this fact, so now we have work done by B in 1 day is 3 by 50. Now work done in 1 day or work done in unit time is always preferable to express it in the form of 1 by n. So 3 by 50, if I want to express it as 1 by n, where n is some number, it will be 1 by 50 by 3. 1 by 50 by 3. So now we can say that time taken by B to complete the work will be equal to 50 by 3 days. This is based on the concept that if you know the work done in 1 day is 1 by n, then the whole work will be done in n days. You can consider this as concept applied is 1, not 1, but concept 2a. The concept applied at this step is concept 2a. Please refer the document on the left hand side, that is key concepts and formulas. So this is the document key concepts and formulas, where I have written down all the concepts that I will apply with a number. Okay, so I have time taken by B to complete the work is 50 by 3 days. So this means that time taken by B alone to complete the whole work is 50 by 3 days. 50 by 3 when expressed as a mixed fraction, because in the options all the options are given as mixed fractions, this will be, I guess, 16 and 2 by 3 days. 16 and 2 by 3 days. So the correct choice is D. D is the correct choice. Okay, let's see. So while I am solving the problem, you can pause the video and take a screenshot. Okay, let's do question number 2. Question number 2. I have no idea why my machine is wrong. Okay, so What is question number 2? A tank with capacity T liters is empty. Okay. If water flows into the tank from pipe A at the rate of X liters per minute, and water is pumped out by pipe B at the rate of Y liters per minute, and X is greater than Y. X is greater than Y. Okay. Uh, X is greater than Y, then in how many minutes will the tank be filled? Then in how many minutes will the tank be filled? Okay. Now we never solved a problem where regarding pipes and tanks where the capacity of the tank is given. We always considered the capacity to be 1, but in this problem the capacity is given as T liters, and we have always considered considered with taps which are inlets or outlets where it was given that a tap can completely fill or empty a tank in a certain number of hours. Now in this problem it is different. The inlet tap, that is pipe A, is filling the tank at the rate of X liters per minute. Now we have to somehow convert the information that X liters uh, uh, per minute as the work done. Now what will remember that in both the mean and work or in time and work done is always a fraction which is a fraction which is a part of the whole work. Okay, so it is given that pipe A fills the tank at X liters per minute. Now the unit of time in this problem is minute. So we will consider all the time units of time to be minutes in minutes. So pipe A fills the tank at X liters per minute. Now we need to find we have to find what is X liters, what fraction is X liters of the total tank. The total the capacity of the tank is T liters. So what fraction? So X liters, what will be what fraction X liters is what fraction of the total tank? So X liters uh, X liters is, we can say, X by T part. This is a fundamental what you can say fundamental concept of fraction. X liters is X by T part of the tank. X liters is X by T part of the tank. So this implies we can say that work done by A, I am not writing pipe, it is understood. Work done by A in 1 minute is equal to X by T. Since we know that work done by a main or work done by a pipe is always a part of the whole work. So work done by A in 1 minute is X by T. So this was regarding the pipe A. Now regarding the pipe B, it is given that pipe B empties the tank at Y liters per minute. So now Y liters is Y by T part of the tank. So this implies that work done by B in 1 minute. Remember, pipe B is an outlet, that is, it is it is emptying the pipe, that is it is draining out water from the pipe, so work done will be negative. So work done by B in 1 minute is equal to minus 1 y by t, minus y by t. Now, okay, uh, so in the system, in the tank, both the pipe A and B are working together. Okay, now what is the question then? In how many minutes will the tank be filled? Okay, so now we need to find what is the work done by both the pipe A and B, work done by A plus B. A plus B means both the pipe A and B are working together. Work done by A plus B in 1 minute will be equal to the sum of the work done by A and B in 1 minute, that is x by t plus minus of y by t. This is equal to x by t minus y by t. If I take t common from the denominator, so okay, so this will be x minus y divided by t. Now it is given that x is greater than y, so this will be greater than 0, as it is given that x is greater than y. If x is greater than y, then x minus y will be a positive number. If and so x minus y divided by t will be greater than 0, positive. So positive work is being done in 1 minute by both the taps A and B, by both the pipes A and B. So this means that water is being filled per minute in the tank. So the tank will eventually get filled up. Okay. So now we can say that, so now the work done by A plus B in 1 minute is x minus y by t. It is all, as I said, it is always preferable to express the work done in 1 unit of time in the form of 1 by n. So x by t, x minus y by t, when expressed in the form of 1 by n, will be 1 by t by x minus y. So now we can say that the tank time taken by A plus B to fill the tank, not empty the tank, because the work done by A plus B in 1 minute is positive. X minus t, x minus y by t is a positive number. So they are eventually working together, they are eventually filling the tank. So time taken by A plus B to fill the tank, will be equal to t by x minus y this much minute. Now the concept applied here was regarding pipes and tank, and that is the concept is 10a. So if a tap can fill an empty tank in n hours, it says that then we have work done by tap in 1 hour is 1 by n. Now this is also true. Let me see if I have. Okay. So concept 7 is that if in 1 hour 1 by n work is done by some taps. Now in the concept I've used the unit of time as hour, but it can be anything. It could also be minute, or it could also be days. So if in 1 hour 1 by n work is done by some taps, then the whole tank will be filled in n hours. Why filled? Because n is positive. Okay, so now we can say the time taken by A plus B to fill the tank is t by x minus y minute. So this was based on the concept of 17. So the correct choice is C. C is the correct choice. Okay, let's do the next problem. 22 men can complete a piece of work in 17 days. They work for 2 days. How many more men should be employed now so as to complete the work in another 10 days? 22 men can complete a piece of work in 17 days. They work for 2 days. They work for 2 days. So, how many more men should be employed now so as to complete the work in another 10 days? So, that is the whole work will be done in 12 days, 10 plus 2, 12 days. Now, for the first 2 days, the 22 men were working, and it is asking for the remaining 10 days. Uh, Definitely, for the remaining 10 days, more than 22 men will be required to complete the work, and it is asking how many more men should be employed. Okay. Mm, uh, let's find out now. Let's find out now. Please note that in solving a problem, you can solve a problem using various concepts. Now, this problem might be could also be solved using the concept of ratio and proportion, but this is but all these problems are based on are problems from the chapter of time and work. So I will try to solve it using the concept of time and work. Let's see. My concept is that I will find out what is the work done in 2 days by 22 men. Now we know that 22 men can complete a piece of work in 17 days. Okay, 17 days. So we can, from this we can say work done by 22 men in one day will be equal to 1 by 17. This is based on the concept of uh, concept of 1a. This is based on the concept 1a. If we are given that in the concept, if a piece of work can be done in n days, now this piece of work can be done by a single person or many person. In this problem, there are 22 men. It is given that 22 men is completing a piece of work in 17 days. So we can say that work done by 22 men in one day will be 1 by 17. Okay, now so work done using a simple unitary method, we can say work done by 22 men in 2 days. Since these 22 men have worked for 2 days, 22 days will be equal to 1 by 17 multiplied by 2. This is equal to 2 by 17. So 2 by 17. So basically this is 2 by 17th part of the whole work is completed in 2 days by 22 men. Okay, now the remaining work, let's find out what is the remaining work. Remaining work, now let's see. So work done by 22 men in 2 days is 2 by 70. Now let's find out what will be, again based on unitary method, work done by one man in 2 days will be equal to 2 by 17, this work divided by 22. So 22 men will do more work. Definitely one man will do less work. So we are dividing by 22. So the work done by 22 men in 2 days was 2 by 17. So we can say work done by one man in 22 days. One man in 22 days in 2 days will be 2 by 17 divided by 22. This is equal to 11. So 1 by 17 into 11. 17 into 11. This is equal to 1 by, how much is 17 into 17? 187. So 1 by 87, 1 by 187 is the work done by one man in 2 days. Mm, how many more men should be employed so now as to complete the work in another 10 days? How many more men? Uh, okay, so what was the work left? What is the amount of work left after 22 men have worked for 2 days? So work left after 2 days will be equal to the total work is 1, and in 2 days the amount of work done by 22 men was 2 by 17. 2 by 17. This is equal to 15 by 17 amount of work is left. Okay. Mm. Now we need to find mm, let's say we have to assume something. Now it is always better if you whatever quantity is being asked, if you can assume that, then it will be easy to solve. But for this you have to be very comfortable with solving a linear equation in one variable. So it is asking how many more men should be employed now so as to complete the work in another 10 days. So let's say let uh, let X men uh, is required to be employed let X men is required, let X more men is required to be employed to complete the remaining work work in 10 days. Let X more men is required to be employed to complete the remaining work in 10 days. Now the concept that I will apply to solve this problem is that I will find out that what is the amount of work that will be done by 22 plus X men in 10 days. Because after 2 days, if we are employing X more men, then the total number of men will be 22 plus X. So after 2 days, total number of men is equal to 22 plus X. Okay. Now, so this implies what we have is 22 plus X men. Now my concept is that I will find out what is the work done by 22 plus X men in 10 days, and then I will equate that amount to be 15 by 17, because after 2 days the work left was 15 by 17, and this amount of work, that is 15 by 17, has to be done by 22 plus X men in 10 days. Okay, where we know that the work done by one man in 1 day. Okay, see, okay, so we can easily find out what is the work done by one man in 1 day. it will be 1 by 17 divided by 22. Okay, so 22 men. So what we are having is, so after 2 days total number of men will be 22 plus x. Now let's find out what is the amount of work being done by 22 plus x men in 10 days. Okay, I know that now I will use a simple basic unitary method. So I know that work done by one man in 1 day will be, we already know that work done by 22 men in 1 day is 1 by 17. So work done by one man in 1 day will be 1 by 17 divided by 22. This is equal to 1 by 17 multiplied by 22. Okay. Now we can say work done by 22 plus x men in 1 day will be equal to 1 by 17 multiplied by 22, this multiplied by 22 plus x. So work done by 22 plus x men in 1 day is this. Now we can say work done by 22 plus x men in 10 days will be equal to 10 multiplied by 22 plus x divided by 17 multiplied by 22. Now this expression, that is 10 multiplied by 22 plus x divided by 17 multiplied by 22, this has to be equal to 15 by 17, because the work left after 2 days was 15 by 17, and this amount of work must be completed by the 22 plus x men in the next 10 days. So we can say this implies that 10 multiplied by 22 plus x divided by 17 multiplied by 22 should be equal to 15 by 17. So we have to solve this linear equation, which is in x. So I can cancel out 17 from both the denominator. I can also divide both the sides, LHS and RHS, by 5, and I get 3 and I get 2. So I am left with and also I can cancel 2 and this 22 by 11. So I am left with 22 by plus x divided by 11 is equal to 3. So this implies 22 plus x is equal to 33. This implies x is equal to 33 minus 22, which is 11. So 11 more men need to be employed after 2 days so that they can complete the remaining work in 10 days. So the answer, the correct choice is choice A. A is the correct choice. Now this the solution could be look like a little complicated, but you have to it is quite simple if you clearly understand some basic fundamentals of unitary method, and also the concept of time and work. Okay, let's do the next problem. Question number 4. P can do 1/4 of a work in 10 days. Q can do 40% of the work in 40 days, and R can do 1/3 of the work in 13 days. Okay. Now 40% of the work you can always consider, the 40% of the work is basically 40%, that is 40% in fraction is 4 by 10 or 2 by 5. Okay. Now who will complete the work first? So regarding P, Q and R, P can do 1/4 of a work in 10 days, Q can do 40%, means 2 by 5, 40% as a fraction is 2 by 5. So Q can do, uh, so uh, P can do, P can do 1/4 of work in 10 days. Now the question is asking who will complete the work first, which means that who will complete the whole work in less amount of days. So we have to eventually find what is the number of days each of them can complete the work alone, that is P, Q and R. So let's find out what is in how many days P alone can complete the work. So P can do 1/4 of work in 10 days. Mm, this implies we can say that P can do uh, not one, the whole work. We can say the P can do whole work in 10 divided by 1 by 4 days, which is equal to 40 days. Now why I'm doing 10 by 1 by 4? There is a concept that concept number 4, if P by Qth part of a work is done in n days, then the whole work will be completed in Q by P. Now Q by P is the reciprocal of P by Q, or 1 by P by Q. So the whole work will be completed in Q by P into n days. So the concept applied was 4. P can do, it is given in this problem, P can do 1/4 of work in 10 days. So we can say the whole work, P can do the whole work in 4 by 1, 4 by 1 multiplied by 10, that is 40 days. Okay. Similarly, we have for Q, it is given Q can do 40% of work in 40 days. This implies the Q can do 4 by 100 of work in 40 days. This implies Q can do 40 by 100 is 2 by 5. 2 by 5 of work in 40 days. Again, applying the concept of 4, we can say Q can do whole work in 5 by 2 multiplied by 40 days. Applying the concept of 4, this is equal to 100 days. This is equal to 100 days. So Q alone can complete the work in 100 days. Okay. Now we have to calculate for R. Now it is given R can do 1/3 of work in 13 days. So this implies R can do whole work in 3 by 1 multiplied by 13 days. Again, concept applied is concept number 4. This is equal to 30 9 days. So we can clearly say that the least amount of days taken to complete the work is by mm, R. R is the least time. So who will complete the work first? R will complete the work first. So the correct choice is C. C is the correct choice. Okay, let's do question number 5. Two printing machines P and Q can together print how much? This is 3 lakh papers in 10 hours. Okay, two printing machines P and Q together can print 3 lakh papers in 10 hours. If printer Q alone can print same number of papers, that is, if printer Q alone can print 3 lakh number of papers in 15 hours, then how many papers will be printed by printer P alone in 10 hours? Okay, the way we will solve is, we will assume that how many, let's say we will assume that X number of papers will be printed by printer P alone in 10 hours. So let's assume X papers are printed. Now printing the papers is the work done. Let's assume X papers are printed by P alone in 10 hours. We are assuming this. Okay. The concept is that we know that Q alone can print 3 lakhs of papers in 15 hours. And from the assumption that X papers are printed by P alone in 10 hours, we will find out how much papers will be printed by P and Q both in 10 hours. And that will be an expression in terms of X, and we will then equate that to 3 lakh papers. Since it is given that two printing machines P and Q can together print 3 lakh papers in 10 hours. Okay. 10 hours. Now you can consider the work done to be the number of papers being printed. Now this question is could be well solved using the concept of ratio, concept of direct and inverse variation. But let's anyway try to solve it using the concept of time and work. So we have assumed X papers are printed by P alone in 10 hours. Okay. Okay. Now let's see. It is given printer Q. It is given Q alone can print 3 lakh papers in 15 hours. Now we need to find how many papers Q alone will print in 10 hours. So let's write it in a different way. So in 15 hours, it is given that in 15 hours Q alone prints 3 lakh papers. 3 lakh papers. So this will imply that using the basic concept of unitary method, in 10 hours Q alone prints 3 lakhs divided by 15 multiplied by 10, this many papers. So Q alone in 10 hours will print this amount of papers, and this is equal to 5, 3, 5, 2, and 3 will cancel. So this is 2 lakh papers. So in 10 hours, Q alone will print 2 lakh papers. And also we have assumed that in 10 hours, P alone will print X papers. So this implies that in 10 hours, P plus Q will print. Now the work done in 10 hours, the work done is equivalent to printing some number of papers. So you can consider that the work done by Q in 10 hours is like printing 2 lakh papers, and the work done by P in 10 hours is printing X number of papers. So the work done in 10 hours by both P and Q will be printing 2 lakhs plus X papers. Now it is already given that in 10 hours both the printing machines P and Q together prints 3 lakh papers. So we can say 2 lakhs, that is plus X should be equal to 3 lakhs. Solving this, we get X is equal to 3 lakhs minus 2 lakh papers. This is equal to 1 lakh papers. So X is equal to 1 lakh. So this will imply, and what was X? X was we assumed X to be the number of papers printed by P alone in 10 hours. So P alone can print 1 lakh papers in 10 hours. I think the problem was solved using basic concept of unitary method. Not much concept of time and work was used anyway. So the correct choice is choice B. B is the correct choice. So this brings to an end in solving another 5 good problems on the chapter of time and work. I hope these problems will give you a good practice of little harder problems on the chapter of time and work. And so I have completed 4 sets of 5 good problems, that is 20 good problems on the chapter of time and work. I will do more in future, so please keep an eye on this playlist, that is Maths 8 Hot. If this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So 4 sets is complete on the chapter of time and work of 5 good problems. Hopefully I will make another 5 or 6 sets, and then in the meantime I will also solve 5 good problems from the chapter of direct and inverse variation, which I forgot to make. So I will also start the videos. I will also start to solve 5 good problems on the chapter of direct and inverse variation. So I will end the video here. Thanks for watching, and until the next video, take care and bye.